If we missed somebody, sorry for it. It was not intentional. Safety first. Assembly point is just outside the building. There is a way to get out in the door right next here. Just get out and go to the front of the building. That's where the assembly point is. So yesterday I texted Andreas. Andreas, what's the purpose of the afternoon? We started a Helinks user group meeting, but what's the purpose of this afternoon? And Andreas told me, yeah, we basically want users to directly interact with each other regarding their top-down experience and also with their 61850 engineering processes. Um, if they don't do top-down, at least a hybrid. So for us, at least the goal was to let the end users speak to each other. So we do not want to be the ones in between. We want you to share the experience with each other. So, agenda for the day. Yes, a good opening with lunch. We all just had lunch. People who are online, we hope you had your lunch, breakfast, dinner, depending on the time zone that you are in. We'll start with the first presentation from Andrew Murray on the topic of, they've been one of the longest users of Helinks, I guess. Okay, so, okay, yeah. And then we have Bart from Tenet, who will also talk us through their top-down experience as well. And then we have Keith Grave, who will join us by our teams. And then last but not the least, Birker. So always looking forward to the innovations in Iceland. Regarding the participants, hey, thank you guys for attending the meeting also physically, but also online. I know for a lot of you guys, it's crazy time zones, especially the people who have to wake up really early on the west coast of the US. And also people who are really awake late in the middle of the night in Australia. One pin I had to be really careful was I saw a sign up from Pakistan and I'm from India, so I had to be really careful where I put the pin, you know. The pins, we have tried to map it a bit. If the latitudes and longitudes are not right, please don't mistake me. I see I missed Iceland. Sorry, Birker. Okay. Some house rules. People who are online, please mute yourself. If you have any questions, put it down on the chat. We will continuously monitor the questions, and at the end of the presentation, we will ask your questions to the speakers. In case we miss to ask your question, later on we will come back to you for the responses. If at all I learned anything from Dutch, is every rule has an exception. That's how the Dutch grammar works. So there are also exceptions for this online group as well. There are two exceptions actually. The first one is Keith. Since he'll be doing the presentation, he will also unmute himself online. And another one, of course, the Reuter family. So Jörg and Paul are online. So they can unmute themselves anytime they want, add to the content. So, and then live here, request to you guys, please reserve your questions to the end. Please ask as many questions as you want. Let's try and keep it interactive. Yeah. And please don't forget to put your phones on silent. And some people also, if you're joining in via Teams, your microphone and your speakers on silent as well. If you run into troubles this afternoon, you can reach out to Andreas or to me. Here are our phone numbers and our email addresses. Please reach out to us and we will try to figure out a way to help you. And we are also recording this session. So at the end, the sessions, you can also contact us for the recordings. And the speakers, I hope it's okay for you if we record you and the sessions as well. So, okay. We wanted to start with a poll. People who are here, people who are online, please go to mentimeter.com and enter this code. The code on top, it's 44238450. The people who are online, the code is here. So in between the questions, if you're bored, you can keep clicking on this like sign because they fly around the screen and it's nice to see visually. Yes. And here's your safety helmet. Nice. York and Paul, I hope you guys are not tweaking these responses. A good set of response. Let's move to the next one then. Yeah, I see it live already. Thank you. Oh, I'll wait for a few more seconds because I see lots of. Yeah, when I see the roadmap, I also forgot to mention at the end, Andreas will also do a presentation for 30 minutes about something from the tool. So I will let him speak. I will not get into the details of it. Good. So, and then the next one. Easy answer for you. Glad to see no response for the last one. And I guess this is the last question that you guys have. Also an easy one. That was it. Thank you for your help with the polls. Now I will ask Andreas to introduce Andrew Murray.
Yeah, I think you already said it. SSEN is probably the customer that's been working with Helinks for the longest time, at least in consecutive years, since 2015 or something around that. So I would call them a little bit of pioneers when it comes to top-down engineering. They've been doing that approach for a long time, and they've refined it over the last 10 years. And I'm really excited that Andy agreed to share their journey. And maybe I should mention the talk's name, A Decade of Helinks, SSEN's Evolution of Top-Down Engineering and Helinks Libraries.
Okay. Hear me okay? Online, hear me okay? Yep. Oh, sorry, I haven't shared on the Teams. Okay. So yeah, hi. I'm Andy Murray from SSEN. First of all, thanks to Andreas for inviting me along to speak here today. It's really good to be at a conference kind of focused solely on Helinks. As Andreas said, we've used this for a long time. And I'm going to take you through kind of how our journey goes and how it's going and how it's progressed over the last 10 years. I'm Andrew Murray. My role at the moment is the lead engineer for digital substations and real-time systems. So in RTS, we're responsible for the substation control system, SCADA, and network architecture. What you see on the map here is like some of the substations that we've worked on over the past 10 years, and also some that are now due for upgrade and renewal with the SSEN transmission network for 2030 proposals. Our very first IEC 61850 substation, oops, sorry. Not that one, that one. Our very first substation for 61850 was in the best possible place where the cursor is now, up in the north of Scotland in Thurso. So far away from many of the main population centres in Scotland. But yeah, that was where we decided to build our very first 61850 substation. The design for which was kind of around 10 years ago, and it was energised about 2015, 2016. So yeah, just some information there on the pathway that we're looking for within SSEN. All of these substations and all of our substations in the last 10 years have been 61850 substations, station bus and MMS only until this year, which I'll come on to when we're going to look at a fully digital substation. So yeah, we've got a lot of experience building this up over the last 10 years. So this is kind of just a timeline of some of my own roles and some of the things that we've been involved in. So the first part when I joined SSE was as a real-time systems engineer, responsible for doing the control system engineering and factory acceptance tests through energisation. 2014, we identified 4 sites in the north of Scotland on the map that was shown there to deploy 61850 within SSEN for the first time. And at that time, 10 years ago, we were early adopters in UK terms. There wasn't really anyone else in the UK looking at 61850. I think there had been some things done with National Grid and SPEN, but we were kind of early adopting in terms of going straight from, we didn't do a pilot project. We just went straight from our kind of hardwired solutions straight into 61850 for these first 4 sites. Early on, Helinks was identified as a kind of vendor-agnostic solution, allowing us to work with multiple vendors in one tool. So that was important for us in the UK, having a multi-vendor approach and not being locked into the different tools from the different suppliers and multiple different tools from different vendors. That doesn't help with interoperability and integration. Yeah, we had many inconsistencies in how vendors were deploying 61850 back then, and we very much found that the software and the firmware of the IEDs was in its infancy. There was lots of kind of integration issues. The software was very young for IEDs. The standard adoption within the IEDs and different vendors and Helinks at the time was also very young, so you got a lot of compatibility issues in between the different vendors. And also we had kind of limited benefits of deploying 61850 because we were going down that MMS only route. We weren't going to realise the benefits of things like goose messaging and whatnot. So yeah, the first 4 sites were delivered successfully and energised, but yeah, we didn't achieve a standard design or delivery model. Those 4 sites were delivered by 2 different contractors. So straight away, there was a kind of inconsistency between what one contractor would deliver and what the other one would do. And I'll get into the next slide about some of the issues there. So from the first 4 sites, we went ahead and decided to continue to build 61850 substations as our kind of mainstream plan for all delivery projects. But we wanted to make it better. So we decided to undertake the substation improvement programme. So the main thing was the learning lessons from what went wrong in the first 4 sites, and the realisation that we had to do a lot of standardisation and try and make the overall process work better, because it was difficult to justify why we had picked 61850 over our kind of conventional hardwired DMP3 solution. The first 4 sites took longer, they were difficult to engineer, there was a lot of issues going on with the deployment of those first 4. So what had changed in our initial kind of move to 61850 We had rapid business expansion, so the way that the network was being upgraded back then, we went from building maybe 2 or 3 substations a year to then building 5, 6, 7 substations over a period of about 2 or 3 years. So we had a lot of concurrent projects that were being delivered at the same time. We had multiple teams and contractors working on those concurrent projects. So I think in the kind of heat of it, we ended up with 3 different project contractors delivering. And again, the issues there are that all the contractors weren't working to the same standards and specifications. If we're honest with how we were at the time, SSE hadn't been clear in terms of what we wanted them to deliver. We weren't giving them consistent information. A lot of what they were doing was actually us, because we were relatively inexperienced with 61850, we were using some of their knowledge to kind of help guide us where we wanted to be. So again, we were taking on board a lot of the guidance from contractors rather than specifying ourselves what we would want. Adoption of new untested technology is always difficult, and just the sheer amount of data from the substation was now up to thousands of digitized signals instead of being limited to the I/O count of devices that you had. So yeah, a very steep learning curve with the new technology. Some of the problems I've listed here, I've probably mentioned some of them already. Lack of documentation from our side. Control system complexity was getting blamed for delay. 61850 wasn't easier at the time than deploying a hardwired site. We had lots of iterations of the signal list, which put pressure on resources. So signal list was inaccurate and not consistent amongst all the projects. When we were sending that to the control room for review, often there would be different things wrong depending on which contractor had delivered it. And there was a lot of frustration about how many times we had to fix that signal list. And every time we had to fix it, we would have to go back into Helinks and go around a process with the contractor to get a new signal list back out of them again. The knowledge for these first 4 sites very much stayed with the contractor. So again, instead of SSE taking on board the Helinks processes and doing the standardization ourselves, we were asking the contractor to use Helinks, but we weren't really telling the contractor how to use it. We were just wanted Helinks to be the kind of tool that was used to deliver the projects. So again, Helinks software is not being used to its full potential. So some of the solutions we looked at for the substation improvement program was, first of all, kind of documentation and standardization for all the devices that we were approving for use in the substation. We had to tighten up our change control processes and have less changes without peer review. We wanted to also try and simplify the control system. And we wanted to test up front the hardware worked with the configurations that we were creating with Helinks. So when we took an SCD file from Helinks, did it actually get pushed through the vendor tool without any issues and errors, and did it work on the end device as you were configuring it? And yeah, try and keep more of the knowledge within SSEN around Helinks and how it works, and provide more kind of training and procedures so that more of our own internal engineers were using Helinks instead of just being reliant on contractors using Helinks and delivering us an SCD file and I/O schedule. So what did we do as part of the substation improvement program? We started where Helinks starts as well. So we standardized on our single line diagrams. We identified our kind of feeder bay designs, the nomenclature we were going to use, what switches, earth switches and disconnectors that we were going to have. We followed that up again with all the bay types, so with SGT as well, bus section, bus coupler. And we standardized on the design of the SLD first of all, and had some bay templates saved in Helinks so that when you were creating your SLD, it was very much a kind of drag and drop solution that you were able to deploy. In terms of signal lists, so we had an equipment list of all the equipment that's approved for use within the network at the time. So we undertook an exercise there to kind of standardize on those signal lists. We compared all the signal lists from the previous projects to date and find out where the inaccuracies were. Just silly things like FMP for first main protection, or the word first, or 1ST. All the contractors may have delivered different descriptions based on the the information they were using, be it from previous projects or just be it misinformation that had crept through. So the documents were created for each piece of equipment, defining the functions and the IEC object references for each signal. And the signals were reviewed and approved by internal stakeholders, our SME and field teams in control room. That was a very important step because when we delivered the first 4 sites, what we found was initially was the protection engineers who were doing the engineering on the relay, they were fine with the description. When we got those signals to site, the field engineers that were commissioning those signals were not happy with the descriptions. So to standardise the signal lists, we had to get everyone's buy-in from the outset to get that. And that included the control room again, because once we had the field teams buy-in and they were commissioning the signal, the control room would then see the signal list and then they would not be happy about something on the list. So you have to get all these different stakeholders involved as early on as you can to make sure there's agreement and it stops unexpected changes coming on further down the project line. So this example here is kind of one of our relays. So we've got a Siemens Railroll relay, which was an older style when we were doing MMS. And you'll see here we have the assign function, which is a drop-down menu. So this IED is one IED that has maybe say a dozen or so functions. You can drop down that list and change the function, which then changes the text. The object references, when we picked them, stay the same. So we try to standardize on one ICD file per IED because you don't want to have many ICD files to manage for the same IED type, but you need to have some flexibility for changing the function of the IED. So we've got one sheet for IED, but within that sheet we have multiple functions for each IED. So we also undertook device engineering. So now we had our signal lists. We imported those into Helinks. We created configuration files for the vendor tools and had the ICD files. So we then imported the ICD files into Helinks as well. We then set up the data flows and communications for our report control blocks, which signals were going to the control room, and at that time also which signals were going to the RTU. The lists may have been slightly different back then. Just now we've got rid of the RTU, we just have a centralized gateway, so all of our signals now go to the gateway, and the device logic was standardized across the board as well. So these were all, some of these are just IED things, not necessarily Helinks thing, but the main point is the standardization of configs and design from top down. For testing and documenting the results, so for this part of the improvement program, we actually procured all of the IEDs that we were going to use, and we had them on a desk and a bench, test bench, and we powered them all up, configured them the way that they needed to be configured, and checked all the signals worked. So we built the signal list in Helinks, we exported an SCD from Helinks, we then took that SCD file and imported it into the vendor tools, making sure there were no incompatibility issues or interoperability problems. And then we tested that as if we were doing a full FAT on the IED to make sure that we could guarantee what was coming out of Helinks was going to work on the devices. And that was very much to ensure that when we gave out the Helinks library to the contractors and the projects, we knew ourselves from our own testing that this absolutely works the way that we want it to. So yeah, SCD file imported into the vendor tool. Multiple files created tailored to the requirements or the functionality of the ID. Importing into the vendor tools, which 10 years ago, there was issues between how maybe the suppliers and Helinks kind of conformed to the schemas. There was issues we had to work through with Andreas Jorg and the team, but we did get there in the end with our signal list and our library, configured and tested by us and tested to HMI as well. So after that, what we ended up with was a software library with all of our device templates added into Helinks for quick deployment. And we also had kind of change control because our top-down process, which you'll see in a second, comes from the documents and then goes all the way through Helinks. So that was just a short picture of our test setup. And then, that allowed us to have our Helinks library released. drag and drop substation builds and documented in training rolled out to the contractors and SSE engineers. So what did we achieve from the standardization? We did achieve a kind of true top-down engineering approach. We have one source of truth, which initially is our specifications, but does feed into the Helinks library. The specifications and therefore Helinks library are under control of change management. So if you want to change the Helinks library, we have to do a change on this document, and that will feed through just now as I show it. We have the initial document at the top. The second slide that's just come in there is a kind of wider spreadsheet, which if you do import into Helinks, you may be more familiar with the Excel table. And yeah, we are taking the information from our document, importing it in through Excel into Helinks, which then gives us the same text. Oops, sorry, the same text and consistency all the way through. So this is really an example of kind of a true top-down engineering approach, where we have our control document at the top, our export for Excel in a compatible format with Helinks in the middle, and then our import to Excel, and on the right-hand side, our object here from Helinks on the library. So all of the information from the spreadsheet is imported into the Helinks signal table. Just for data management and standardization purposes again, this follows now through all the way from the document, all the way through to Helinks, all the way through even to tools such as IED Scout, Station Scout, and our HMI and Control Center. And one thing common throughout is the description, the object reference, the REMAs, whether it's going to the HMI or the RTU at the time. All of this information is standardized all the way through Helinks in the SCD file into all the tools that you use. The main benefits from the kind of exercise were complete signal list standardization, version controlled Helinks library was given to all developers, and a true kind of drag and drop library for Helinks, where we can take virtual IEDs from the library and drop them on the page very quickly. That gave us a much more consistent design and delivery across all of our partners, and a much reduced configuration time, where I think an average size substation, by that I mean maybe 10 to 15 bays, can be engineered in a few days now. And the review and approval time for signal list is vastly reduced because there are no surprises in the top-down engineering approach. Everyone agreed to the signals up front, as I said, with the field team being key, the control room being involved. So now when people get a signal list, they've already seen most of the signals that are on there before. There's no surprises. Some of the issues that we do face are still, especially in the legacy devices, where devices don't support top-down engineering at all. They'll maybe only allow you to import a CID file or export a CID file. They won't allow import of ICD files. The only way we can get around that really is by just falling back to the Excel import sheet per device. And we can't add it to the library, but we can have a spreadsheet that's still controlled in that way. So I think one of the examples of that is the MyCom C264 BCU, where you can't put an ICD file into that device. You can only get a CID file from it. This was just some examples of just some of the substations we've built. Most of this is all templated in terms of the bays. We can just drag and drop that, put on the bus sections, do all the nomenclature updates, and so on. Just to give a kind of size and number of IEDs there with the same substation. Most of the substations we build are kind of between 70 and 100 IEDs, I would say, at the moment. So quite big substations. Some of the digital ones and the ones we're looking at in the next kind of years to come are going to be the biggest we've ever built. So it'll be interesting to see how we can scale that up as well. And then, yeah, the benefits of having the drag and drop facility. We have our BCU on the left connected to all the system equipment, and we have our IEDs on the right of the blue line, which are very much kind of just straight from the Helinks library. And a few hours you can put together a fairly decent sized substation. So moving on to Project Trends, which is the name for our fully digital substation. Trends is a transmission network digital substation. And the idea for Project Trends is to move on to full Goose and SV for the first time and get the full benefits from 62850. So some of the benefits we're looking for there are CapEx savings, such as the reduction of the copper network, the copper hardwired signals within the substation, faster construction and testing, especially around the testing of the FAT and the site acceptance testing when it comes to testing of the digital signals in Goose and sample values. Improved safety and data. So again, we're going to have much more data available, even more signals with Goose and sample values. And yeah, the control system implications are very familiar to when we first moved from our hardwired solution to 61850. We've got Goose and SVs for the first time. We've got a multi-vendor solution. We've got new products with a steep learning curve. All of these things are things that we learned from when we first deployed 61850 as MMS only, with new equipment and suppliers again to bring us up to date with IEDs that can perform digital functions. So how are we going about doing the digital substation? We're going to follow the same standardization and learning from what we have, so very much top-down engineering. We identified Goose and sampled value signals required for each IED, initially as an Excel exercise, just to help us familiarise ourselves with the parameters that were needed. So we were fairly new to the kind of MAC addressing, app IDs, VLANs and priorities and things like that. So we did a kind of Excel mapping sheet for a one feeder bay to allow us just to see which signals need to go between which IEDs. And we created a basic application scheme in Helinks for one feeder bay. So in this example here, we have our first main protection Goose outputs, and these signals are getting sent to the PIU1, BUP, TMP, third main protection, second main protection, and our PIU2. So we've now created this template saying that from our first main protection, we need to send all of these signals to all of those other devices. And from there, we tested that again on hardware. So we had the hardware on the test bench, making sure every step that the files coming out of Helinks were compatible with the vendor tools and they were interoperable and working as expected. And then it was very much kind of over to Helinks. Once we were satisfied, we templated the application, and in Helinks, we then get this matrix table. So again, on the top line, you'll see Bay 7, and we're just sending the Goose messages from Bay 7 to Bay 7 in this instance. There's no kind of inter-bay communications in this case. We added then Bays 3, 2, and 6. And just by checking the box here, Helinks is able to do the rest from the application that you've taught it from the initial deployment and build the rest of the Goose messages for you. So that's the same for this instance here for the sampled values, where we have the tick boxes for the sampled values between PIU1 and the bay. And then also down here, you'll see we have the busbar protection, where we're also sending the sampled values from the bay to the main busbar protection IED. So all of this was accomplished by using the matrix table within Helinks in the applications. And what that gives you is basically the top box is the box that we had in the initial slide. And then Helinks does the rest by creating these other messages for you. So yeah, that was a lot of work that was provided by the functionality of Helinks, basically by a checkbox on the matrix of the application configuration. So very, very much time-saving exercise. Standardization, because you're using the template that you've designed from the outset. You still have control over MAC addresses and priorities, if you like, depending on how you decide to configure it. And this is something else that we're now using the SCD file and Helinks for. So in our digital substation, we're using SSEN technology, which is software-defined network with Cell Schweitzer as our partner in delivering that. So SSEN by default is a deny by default technology. meaning basically every switch is a firewall with everything disabled. There's no traffic allowed between any devices. What SDN allows you to do with the tools that it has is take the SCD file, and it will actually parse the SCD file and look at the goose IDs and the goose parameters and sampled values parameters within that, and use it to configure the SDN network. So the network is defined by the SCD file as well, which is even more engineering payback, I kind of like to call it, in terms of investing time in Helinks. You get the full benefits from configuring your IEDs, obviously, and your goose and your SVs. But if you take it to other levels and use the SCD file for other things, this method allows you to kind of fully configure a deny by default network using only the rules that are available within the SCD file. And in this case, you can see that this message is taken from Helinks. The software within the SCD tool identifies that that's the goose between PIU1 and the first main protection. It puts the MAC address, the VLAN ID, and the priority from the SCD file from Helinks into the match fields, and then it creates the flow specifically for that goose message. So if someone tries to send a goose message that has a slightly different MAC address or VLAN ID, the SDN will block it straight away and put it out through unplanned traffic for your intrusion detection system. Yeah, so that's something else that we're really doing with the SCD files. And as another kind of benefit is additional top-down engineering approach, which means that Helinks is only the one source of truth, not just for your IED configuration, but now also for your substation control system network configuration. So we've seen a lot of benefit on that. If we have a network of 10 or so switches, we can reconfigure that whole network in about half an hour, 40 minutes by using the SCD file to configure all the parameters within that. And yeah, one source of truth is Helinks. It means that our libraries are in Helinks, our network configurations in Helinks, all our goose messaging's in Helinks. It was really good to have that as a kind of overall independent tool. So just to kind of cap up where we are, without doubt, Helinks has helped us to achieve a digital solution more quickly and efficiently than we thought. We thought there would be a lot of work to do in terms of Excel sheets up front, identifying every individual goose message. But the application tool within Helinks and the matrix really does help us cut down on that. If you do your top-down engineering for one feeder bay, essentially you've done it for every feeder bay within the substation if you have that level of standardization. So yeah, it's essential to allow the delivery. We've found compatibility issues are mostly completely eradicated. We've not come across the issues we did early on, where we were exporting SCD files and vendor tools were having difficulty with those. Your main suppliers that we're using on the digital substation are Siemens, Hitachi, and Cell Schweitzer. We've not seen any issues with the output from Helinks in terms of importing those into the SCD tools. I think for the most part, everyone's maybe finally caught up with the standards and the schema, and the output of the vendor tools and what they'll take in is a lot more consistent than it was when we first started on our journey. We're excited about some future features that we're looking at. SDN is obviously one of the things that we're also getting added benefit from using Helinks as our kind of centralized tool. And we're looking at ways to integrate further with our HMI and have even more integration between Helinks and our control systems. So yeah, that was me. Thank you. I'm just going to grab a drink more.
Best. Okay, thank you very much, Andrew. It was very exciting to see this all at once explained, because I've always kind of over the last 10 years, caught snippets here and there, supported you a little bit here and there, but now to see it all laid out is great. So let's start off with some questions. Does anyone have any question? Yes. So the remote people can.
Yeah, well, first, Alejandro Rodriguez, our products. We're evaluating the tool now, so we are not experts with Helinks by any means. but we do know 61 and 50 standards. So basically, my question is that I'm assuming that all these, because you mentioned that you have hardware tested and approved, right? So your solution is tied to specific protection relays that were tested, and they are sitting in an approved vendor list for SSEN, I guess.
List of IEDs that we allow our contractors to use on the network. So because we control the IEDs that they're allowed to use, we could then standardize on the signals that was in each IED and the ICD file required to configure each IED. So yeah, the first thing we had was just an approved list of IEDs that all the projects were allowed to use. Anything out with that. So there are things like point on wave, which has kind of recently come in as a more utilized technology. If there is a new IED, we ask that we are provided an ICD file for that device and a signal list in the format that's compatible with Helinks so that we can review it. And obviously that's a kind of ongoing process. If there's new devices to be added, we ask that it goes through the same or similar FAT process before it is added into the Helinks library. And then the future projects can then get the benefit of it as well.
Okay, so I guess you don't deal a lot with LV IDs, right?
No. I'm transmission, so yeah, we're mostly the transmission voltages. Yeah, not so much the LV.
Yeah, so that will be maybe more a question for. I don't know, maybe that's a very specific use, but this technology could be, I guess, extrapolated to also.
Yeah, so I work for SSE Transmission. We do have SSE Distribution, who have also worked with Helinks, doing a very similar project. We are separate entities, but we discussed the approach that we took. I do think they have a bit more difficulty standardizing on the signals. They've got a bit more going on with some of the distribution things. It's not as easy for them to do standardized SLDs. And also when you're going back to do older sites or brownfield sites, you're maybe just upgrading the SCADA. You can't always get the level of standardization you want when you're building a brand new substation kind of thing. So.
Thanks. And the second question is regarding the SEN. Okay, because I think it pays off, right? So well, you invest a lot of time creating an SCD file, and then that's actually going to become your foundation then for setting up your SSEN. So I would like to understand how user friendly was the process of setting up the SSEN part. I can just go with the SCD file and then put it into the flow controller and that's it.
Yeah, so there's two parts to the SSEN configuration. The SCD file tells the system about all the 61 and 50 aspects. So MMS, who's the client servers, Goose, publisher subscriber, and sample value publisher subscriber. The second half of that configuration is done in a Microsoft Visio drawing, where you have to tell the system about all the other things that are in 61 and 50. So things like PTP, SNTP, syslogs, the ports that you need open to allow vendor tools to actually communicate with the IEDs to configure them, tools, ports open for things like Triangle Microworks and Station Scout so that you can do diagnostics. So anything that's not in the SCD file is catered for in a Visio file, which then also forms the full flow controller configuration.
Okay, so that process was included because I think you said you were able to configure a system of how many? I think it was you said.
So in our test environment, we have about 8 switches on LAN A and 8 switches on LAN B because it's a full PRP network. Yeah, we can wipe down all those switches and reconfigure the whole network without logging into any of them. You do it from a centralized controller. It takes about 40 minutes, 45 minutes to fully reconfigure your Ethernet network.
Thank you.
Okay. Anyone else with a question? David.
You talked about version control and version management in Helinks. How do you do it? Or do you do it with Excel, or do you check in your files, something else?
Yeah, so initially it's version control of the documents or import documents. So they're all now version controlled. We have version control over the ICD files that we use. That is a manual process at the moment. We took MD5 hashes of all of the ICD files that we gave out as part of our Helinks library, so that if we need to check the Helinks project in future, we can check the hashes of those files to make sure that they are the files that we've given the contractor, and they're part of our library, especially if we started to hear that or this file doesn't work with the IED. Because we did all that testing from the top down, it suggests that somewhere along the line something's changed. Someone's maybe manually changed the library, or they've used an incorrect or old ICD file from a different project. So that is a manual process. In terms of overall Helinks project, we do use the archive and history tab feature to make regular backups of our Helinks. But yeah, I think it's something I've fed back to Andreas on, that we could have some improvements in Helinks in terms of version control of the library and some of the files that are used within Helinks, and how the change management and version control is handled within Helinks itself. So it is quite a manual process just now of the library and signal lists that you have to undertake.
Okay, anyone else with a question? Not, then I have a question. You mentioned at the beginning of the talk that the initial 4 projects that you did those before you even did a pilot.
Yeah.
In retrospect, do you think that was, you should have done a pilot, or did it work out fine, or what do you think you could have done better there?
No, definitely we should have done a pilot. So I joined in while those designs were already underway. It's difficult to find the person within SSE that found that was a good idea at the time, but definitely it was a new technology, a move away from DMP3 protocol, which was our standard protocol. And at the time, we very much had a serial world that we lived in, so RS-232 connections, DMP3. The step alone from that to Ethernet was big, but the change of protocol as well was too much for everyone to kind of undertake, including the field teams when it came to commissioning. And one of the other issues we had was we didn't get the field teams involved in the initial FATs and site and testing either. So we tested it all at FAT. We then took it to site, and the field guys then had their say, and there was a lot of re-engineering done again there as well. So yeah, that's why we've undertaken Project Trends, to make sure that we are doing a pilot project. So Project Trends is the pilot project where we've documented and proven the concepts that we want to use in the digital substation. This summer, we're deploying that on a 9-bay substation near Aberdeen in Scotland to a full digital substation site, and that'll be our first full digital deployment using the learning from Project Trends. And that's an in-house delivery team as well. So instead of allowing the contractors to do the configuration of the control system, we've created our own team within SSE to undertake that as well.
Okay, thank you. And so when you describe that, with your journey now, SSE is basically in the driver's seat, right? You have full control of your data model, and you're taking the engineering decisions.
Yeah.
And from my experience, when people start working with 650, they are flattened by this wall of complexity, and it's incredibly difficult to kind of find your bearing. So how was your experience with your team, that you didn't just need to learn about using a new software, but you also kind of need to learn about the standard? And what was your strategies? What would you have done differently, maybe in retrospect, to get past that wall of complexity?
So really training up front and learning about the protocol up front, what's the limitations, what are the differences. I think Helinks, initially we had good training from Helinks, but I think you also need to do things with other vendors and suppliers who understand 61850. So Omicron, Triangle Microworks, the vendors themselves, is try and get involved with the vendors and go on their courses to see how they deploy and implement 61850. Yeah, I think it's only once you start to undertake the configuration yourself, which is another issue that we had early on, was that our intention was for the contractors to use Helinks to deliver it, but that didn't actually tell us anything about how 61850 worked. So we got those first 4 substations, but as a business, SSE and the personnel working for them still didn't really know very much about 61850 at all. So I think all I can really say is for that is just get your hands on and start to do it yourself. Go to training courses, conferences, but once you've got an IED on the bench and you can use configurations with the vendor tools and SCD file from Helinks in it, that's when you really start to understand and learn how everything's working together.
Okay, and these changes that you implemented, also working with your contractors and within your organization, it's not just using a new tool, it's a whole new workflow, right? And it requires some organizational changes.
Yeah.
I was wondering, have you encountered resistance against that? Did you have to do a lot of convincing? Did you have to convince the contractors that this library approach is viable? Or was this something where everybody was on board and then saw the benefit right away?
Definitely resistance from different areas. So I think some of the contractors initially, they did need more help in terms of what is it that you want, because they would give us a signal list and it would go for review, and the control room would say, no, that's wrong. And they would say, but how can it be wrong? Because you haven't told us what it is you actually want in the first place. So that's the kind of first thing. So for that, the contractors did want more guidance in terms of, well, tell us what you want up front and we can do it. Some of the contractors are a bit resistant to the use of Helinks because it's not their own tool and their teams and parties aren't familiar with it. But we kind of have to offset that by the benefits that it gives us, it being a completely kind of vendor agnostic solution. We don't have to have a Siemens SCD, an ABB Hitachi SCD, and another SCD all managed differently. And that only becomes more important when you go digital, because you have your publisher subscriber model as well, in terms of the goose going between the substations and different vendors. The other resistance was very much the field teams. In terms of change of protocol, we really should have done more with them up front about the difference in movement to 61850, and we still face that in the digital substation environment, because now we've taken all their wires away as well. They don't need a multimeter anymore, they need Wireshark. So the whole point of the trends team was to bring that knowledge in-house, first of all, with the kind of senior delivery team of trends, and now bring along this first substation that we're going to develop, bring along that field team with us. Because yeah, it's a massive step change for them that they don't have wires to go and bail out anymore. They need to look at Wireshark captures to see if their signals are going. And I have to say, like, Triangle Microworks is excellent for that. That's one of the key parts of that, is visualizing the goose messages in the Test Suite Pro.
You're doing that with Test Suite Pro, you said?
With Test Suite Pro, yeah. It gives you that visualization of almost like a drawing of where the wires are, but it's a goose message instead, and you can see the goose message moving through the network as well. So, yeah.
Okay, thank you. Does anyone else have a question? Not, then I have another question. This one's a little bit more technical. Are you maybe you've already done this, maybe not, I'm not sure. Have you built your own logical node types? And if not, do you want to do something like that, build your own namespace to have a data model that is completely under your control? Or are you happy with using the data model that is provided by Helinks, what we ship with, and that is provided by the vendors as well?
So today we've very much stuck with what the vendors give us in terms of logical nodes and data models. We've not found an application yet, especially with the newer devices where we've had to look at something like our own namespaces. The early projects we did find that a lot of the signals within the IEDs were GGIO, which makes it harder to look at and understand what the signals are when if you're just looking at the object references. With the digital substation, we're finding that more of the vendors have actually adopted the proper logical nodes for what they're supposed to be used for. So things like LCCH for Ethernet monitoring, and LTMS for PTP, which obviously is very important in the substation, monitoring the time synchronization. More and more of the vendors seem to have adopted the proper logical nodes for the function that they're intended for, whereas the early substations, most of our signal lists are GGIO 1, 2, 3, 4, 5. Hardly anything was properly mapped even to some of the protection functions like PTOC and things.
So. Okay, thank you. And I have one more technical question that I just thought of, because you talked a little bit about qualifying and selecting the IEDs that you use. And I was wondering, so in 90-30, we have this new notion of a specification IED, and in Helinks, you have this IED crafter where you can build an IED data model out of specification nodes. Mm-hmm. Is that something that you're using already to qualify IEDs, or that you're planning to use to really give the vendor this formal data model in form of an ISD file?
Yeah, so for the initial configuration of our digital substation, we tried to keep it as generic as possible using the method you just said. So we built our IED and we brought in the logical nodes that we thought would be interesting or that we would need. We did use the IED crafter and provided that, but I think the only supplier we had at the time that was looking at integrating that was Hitachi. So again, it's very much a vendor thing, but we can see the benefit of having that one model and saying this is our first main protection IED, this is what we want it to do, and sending that model out to all of the vendors and seeing if they're compatible or able to provide that. That's something I think maybe the next step of the iteration of the digital substation will happen, but not all the vendor tools were there for that in terms of wanting to support that just yet. So,
okay. Thank you.
Okay.
Okay. Are there any more questions in the meantime? No? Okay, is there any question remotely? Okay, then thank you very much, Andy. It was really interesting. And before you leave, oh yeah, yes, round of applause, please. Yes, of course.
Thank you.
We have folks at SPIE picked out these presents for you. You have a cheese, I don't know what's in English, a cheese grater, cheese slicer.
Okay.
I hope this is airplane safe. So I don't know what's going to happen now at the security line.
Okay.
And a little cutting board with your name on it.
Okay.
Yeah. Okay.
Right. Thank you very much.
Thank you very much.
Thank you. Thanks, Andreas. Yeah. Cheers. Thanks, everyone. I'll just take this out.